Hi everyone. Today I'm going to talk to you all about an important topic in air quality, volatile organic compounds. In this video, you will learn what a volatile organic compound is, where they come from, how we measure them, and how they affect our health. Volatile organic compounds, or VOCs as they're more commonly called, are gas phase pollutants. Remember that gas phase pollutants are made up of very small molecules, not particles. For volatile organic compounds, let's first consider the word volatile. Volatility is the measure of a substance's ability to become a vapor from either a liquid or a solid. Remember that when a compound is a vapor, it is in the gas phase. To look at volatility in more depth, let's first consider a glass of water. We know that if we leave a glass of water out in the open, the water in this glass will start to evaporate. If you left the glass out in the open for a long enough time, eventually all of the water would evaporate. This is because of the process of the liquid water molecules becoming gas called water vapor. With every liquid, there is a unique fraction of the liquid molecules wanting to escape from the surface and become a gas. Once that fraction of liquid has become gas, the substance has reached what we call a natural equilibrium. Volatility is essentially how large of a fraction of the liquid molecules escape to become gas, and each liquid has a unique volatility. With water, only a small fraction of liquid needs to become gas to reach the natural equilibrium. The only reason that eventually all water would evaporate is because of other things happening in the air, moving the water vapor around. As the water vapor moves away, the glass of liquid water is constantly allowing a small number of molecules to escape into the gas phase to maintain the natural equilibrium. Since the fraction of liquid molecules that need to escape to become gas is so small to reach equilibrium, water is fairly non-volatile. Now consider ethanol, which is a principal type of alcohol and is much more volatile than water. If you put some ethanol in a cup, significantly more ethanol molecules will become gas phase. The forces that keep ethanol bonded together are much weaker than water, so more ethanol molecules can escape into the gas phase. Thus, more ethanol molecules need to become gas to be in equilibrium, which means the compound is more volatile. There's no exact definition of what is volatile and what's not. Usually, we just compare substances and state which substance is more volatile than the other. In our earlier example, ethanol was more volatile than water. The term organic is included in volatile organic compounds because all VOCs contain at least one carbon atom, and in chemistry this is referred to as an organic compound. Thus, we have the term volatile organic compounds. Now, I bet you're wondering where VOCs come from. The first answer to that question is simple but expansive. Any organic compound that volatilizes, which means entering the gas phase at room temperature and pressure, is a VOC. This is a very general definition that includes hundreds of compounds coming from both natural and man-made sources. It's important to note that not all VOCs are toxic, especially those VOCs that are found in nature. From man-made sources, most things you can smell are made up of VOCs. Think of those scratch and sniff stickers you loved as a child. A portion of the chemicals that make up those scented stickers are VOCs. Cigarette smoke contains benzene, which is a VOC that can lead to increased risk for leukemia and cancer. Gasoline vapors at the gas station? VOCs. Even items you use on a frequent basis in your home often contain many VOCs. These items include cleaning products, hairsprays, perfumes, colognes, air fresheners, paints, and so many more. Additionally, VOCs can be produced from incomplete combustion of carbon in fuel. If there is not enough oxygen present during combustion for all of the carbon to convert to carbon dioxide, VOCs are released along with other byproducts. VOCs can also come from natural sources. In fact, one study found that 88% of global VOCs come from natural sources such as trees, bushes, and animals. For example, think of walking through the forest and smelling the lovely smells on a sunny day. The pine smell is from VOC emissions from trees. But don't worry, VOCs from nature are often much less toxic to human health, and sometimes are even completely non-toxic. Now, let's talk about how we measure these volatile organic compounds. VOCs are measured in parts per million, which is referred to as ppm. This tells us how many molecules per volume of 1 million molecules are VOCs. Often, we can only measure the total amount of VOCs in an area, and not which specific VOCs are present. With the air quality pod provided by the AQIQ program, for example, we can only measure the total amount of VOCs present. To get a more specific analysis, we would need much more expensive equipment that requires a professional to use and maintain. For more information on these expensive tools, please see the video on this website about air quality measurement technology. The air quality monitoring pod in particular uses a Figaro volatile organic compound sensor. This sensor is inside the pod, and air is then pumped into the pod with a small fan. The VOCs in the air react on the surface of the sensor by increasing conductivity of the sensor, which is how well electricity flows through the sensor. The increase in conductivity of the sensor is proportional to a voltage that the sensor measures. The concentration of VOCs in the air is also proportional to the amount of VOCs reacting on the surface, so thus these voltages can be used as a measurement of VOC concentration in air. To convert the voltage measured by each sensor into units of parts per million, air quality scientists or engineers must take each sensor individually and expose them to various known concentrations of VOCs. This allows the scientists to determine which voltage levels correspond to which parts per million level, which is a process called calibration. There are many health impacts associated with VOCs, and each VOC has its own toxicity and potential for creating health concerns. Remember that VOCs from nature are generally much less toxic than human-made sources, or are not toxic at all. So there's no need to worry about any of the VOC exposure you get from activities like taking a hike through the forest. Man-made VOCs can often have poor health effects when exposure is very high. When exposure is high for a few hours to as long as a few days, symptoms might start to occur. These symptoms may include eye, nose, and throat irritation, headaches, nausea, and vomiting, dizziness, and worsening of asthma symptoms in those with asthma. Exposure to heavy levels of VOC for many years could potentially lead to even worse health effects, such as cancer, liver and kidney damage, and central nervous system damage. The level of VOCs you see in your daily life are usually not high enough to be of great concern, but it is always a good idea to minimize exposure as much as possible. The best way to minimize exposure would be to avoid products containing VOCs, but that's not always possible. To minimize exposure of VOCs from products we use often that emit VOCs, it is recommended to use these products in well-ventilated areas. Paint and use cleaning products with all windows and doors open, and use hairspray and body products with the bathroom fan on if you have one. Otherwise, leave the door open. Thank you for watching this video. I hope this has been informative in telling you all exactly what a volatile organic compound is, as well as where they come from. Hint, smelly sources. I also hope you now have an understanding of how the air quality monitoring pods measure VOC levels and the health impacts these pollutants can have on your life.